This is a repair video in which I will look at trying to fix a problem with an Agilent 1672G logic analyzer. I have a number of these instruments. In fact, the previous videos you'll have seen me using the one at the back there. And this one has a fault that looks very serious when you first see it, but in reality it's normally something fairly simple, and I'm hoping it's the same with this one. These logic analyzers are fairly common and they're in plentiful supply on eBay for good prices. There's a range of them from the 1670G up to the 1672G, and the only real difference is the number of channels that they have. Other than that, they are pretty much identical. The only differences between the ones you will see on eBay tend to be the options that they have fitted. So the one at the back has got the scope option, which is quite useful because you can do signal capture in the digital and analog domains at the same time. This one's a bit more basic. It did have the pattern generator when I bought it, as did the 170, but I tend to remove that because I don't use it and all the cables are permanently attached to the card, so it makes it a bit cumbersome. Now the fault this one has is when you boot it up, it comes up, or sometimes it comes up with very weird error messages, and other times it will boot up okay, but it will then crash when it's doing various things. So it might be you're doing a run or a capture and it will suddenly crash. Essentially it freezes and then none of the keys work. The only way to get it going again is to reboot it. Now, as I said, I've got quite a few of these, so I've seen this fault probably at least 3 times before, and it's always been the same thing. Unfortunately, it does tend to cause them to be scrapped. People think it's a very serious problem, and it is a fairly easy problem to resolve. So I'm going to show you, hopefully today, how to fix the fault. As I say, it manifests itself as various weird error messages popping up, but it's fairly obvious what it is when you look in more detail at the instrument. If you can get it to boot, if you go to the real-time clock or various settings, enter the settings that you want, switch it off, wait 10 minutes and then go back, you'll see that the settings have disappeared, or it then shows kind of random nonsense data in those locations. And anyone familiar with this type of instrument will know pretty much straight away where I'm going, and that it is most likely a problem with one of these. So DS1387, so Non Volatile Ram, and we'll look at this in more detail in a minute once I've got the board out of the instrument. So give me a couple of minutes, I'll get the board out and then we'll have a look at it. So this is the board that I think the fault lies in, and I believe it is most likely the non-volatile RAM, and I think it's just the case of the instrument requires certain values, and when it gets rubbish data, the firmware can't handle it and it behaves very strangely or just crashes. I do have spare NVRAMs, but in this video what I'm going to do is try to repair the existing one. They are quite rare, expensive, and if you can't get hold of one, then hopefully this will help you resurrect a piece of equipment that that uses one. If you can't find a spare, then this is a good option. It's a permanent fix. It will last as long as the original if it can be done successfully. The first step is to get the NVRAM out of the board, so I'll do that now. I won't bore you by videoing it, it's just usual desoldering it and popping it out. But what I will be doing is putting a socket in rather than soldering the NVRAM back into the board. So if ever I do need to replace it in the future, I can just unplug the old one and then plug the new one in. Okay, so I've desoldered the NVRAM module. There's no damage to the board, luckily, and what we can now do is turn our attention to the module itself and how we're going to go about repairing it. It's obvious if you look at the bottom of this module. I don't know how well this will come out on camera. This is nothing more than a static RAM chip. This is actually the base of the chip, and these are the pins from the chip itself. And what they've done is create a little plastic housing. They've put a small battery in the bottom of the housing, connected it to a couple of the pins on the static RAM, and then potted it and that's all this is. There's nothing special about it. There's no battery management in there as such. It is just a static RAM with a battery attached to it. And this becomes even more apparent when you look at the datasheet. So there are several versions of this. The 1385 is a version of the memory chip that requires an external battery. So you'll see that pin 20 it says VBAT, and pin 16 says ground. Now this ground and the VBAT would normally have a battery attached externally, whereas on this module 1387, which is the one we're looking at, pin 20 and pin 16 are identified as not connected, and in fact they don't come out of the module. So they're here. Now they haven't been cut off. What the manufacturer did is they took the pins that would normally extend out of the bottom of the IC. So this is how the pin would normally be arranged, and what they did is they bent it upwards. So the ones that they didn't want coming out of the bottom of the module, and more specifically the ones they wanted connecting to a battery, they simply bent them up on the IC before they potted it and then connected it to the battery. So if you imagine this is the inside of the module housing where it's been potted, and there's a battery in here that's connected to the two pins that have been bent up. So all we need to do is gain access to the pins through the side of the potting box, and they're in here. So all we need to do is to remove this outer surface just down until we get level with the pins that have been bent up. We can then disconnect the pins from the internal battery. We don't want that connected anymore, and then we'll attach an external battery. You could do this in one of several ways. You could either bring the pins down to the board and fit a battery to the board, but what I do is attach a battery piggyback style to the top of the module, and then I solder leads from the battery itself to the pins. So what I'll do now is I'll do this off camera because it's a bit fiddly, it takes a while. I'll remove the material from these two locations down until I find the pins, and then I'll get back on camera and we'll go from there. Okay, so this is the result after a few minutes filing. You can see that I've exposed the two terminals going to the IC. These are actually the pins on the IC that, as I said earlier, have been bent upwards. I've also broken this connection between the pin on the IC and the internal battery because I don't want the old battery connected to the new battery. So if we now test that, we should find that there is no voltage on the pin on the IC, which there isn't, but there is still a voltage on the internal battery. You now have several options as to how you go about connecting the new battery. You can either glue a coin cell to the top, solder some flying leads to it, and then solder those to the two pins on the IC. I'm lucky enough to have a battery tab welder, so what I've done is make up a special battery that fits into the two slots that I've filed. So what I'll do now is solder this in place, and then it's ready to go back into the instrument. This is the final result, a fully functional non-volatile RAM. Total repair cost was about 60 pence, and it's probably going to be good for another 10 years. At that time I can just pop this cell off and fit a new one. So hopefully you found that useful or interesting, and there's really no need to scrap old machines because you can't get hold of these devices. So I can fit this back into the instrument, and hopefully it has resolved the issue. Okay, so just so you're not left wondering if it did fix the problem, this is the machine reassembled, boards refitted, and I'll boot it up and see if the error messages have gone away. Just turn the light out so you can see the screen more clearly. And no more error messages. I'll leave it running for a while and see if it keeps going. As I say, it used to lock up, but it's looking good so far, and it was a very easy fix.